G'day team. All right, so what are we going to be looking at today? Atomic structure. Okay. There will be a fair bit of revision in this. There may be a couple of new things, but nothing should be too surprising. So what do we know? Well, all matter is made up of atoms, and atoms themselves are made up of smaller subatomic particles called protons, neutrons, and electrons. We also know that atoms contain equal number of protons and electrons, so this gives them an overall neutral charge. So if we were to look at the actual structure itself, we've really got a couple of components. So in the middle you have what's called your atomic nucleus. Okay, your nucleus is made up of your two largest subatomic particles with your protons and your neutrons. Your smaller electrons are found in shells or orbitals around the nucleus. Now, what do we need to know about each of these subatomic particles? Well, each subatomic particle has a relative charge. Okay, so protons have a relative charge of +1. So if there's one proton in the nucleus, it's +1. If there's two protons in the nucleus, it's +2. If there's 7, it's +7. And because only protons and neutrons are found in your nucleus, the overall charge of your nucleus is positive to the extent of how many protons you have in it. We also know that we have an atomic number. Your atomic number is found on your periodic table. It's the smaller of the two values that you're given for each element. This is the number of protons that are found in the nucleus. Your electrons. Let me just move myself up. Negatively charged. So they have a relative charge of -1. They occupy orbitals or shells that have certain capacities surrounding your nucleus. Okay, and the negative charge of your electrons is what holds them in towards your protons in your nucleus, so your positive and your negative attract. There's a specific configuration of these, and we will look at electron configuration later on. Let me just go back. Couple of ones that you need to know of. You've got your outer shell electrons or your outermost electrons. They're what are referred to as your valence electrons. We'll talk about them a lot. There's a maximum number of electrons that can occupy different orbitals at one time. Again, we'll talk about orbitals later on. The main one is that there are equal numbers of protons and electrons within an atom. Okay, this gives an atom an overall neutral charge, but what we do know is that electrons can be lost or gained, and what this does is it creates what are called ions. Okay. We then have our neutrons. They have no charge, so if we're looking at a relative charge, it's 0. Found in the nucleus, and they can vary between atomic structures and give us what are called isotopes, and we'll have a look at isotopes later on in this video. But let's have a look at a couple of things that we can use this information to work with. So the idea is that your atomic number tells you the number of protons. We also have an atomic mass that we're given for each element. Now, on your periodic table, this is generally a decimal point. It's what's called your relative atomic mass. We will look at relative later on. Normal atoms actually just have an atomic mass which is a whole number. Okay, and as we go through this table, what you'll find is the mass number is a full value. It will vary from what's on the periodic table. The reason is we're using information that we're given about elements to figure out that. Okay, no actual element in nature will have an atomic mass that is a decimal. Okay, you can't have 0.16 of a neutron. It doesn't work that way. All right, so let's have a look at filling out this table together. Beryllium's already done. We'll work through that in a second, and then we'll use a periodic table to fill out the rest of the information before we have a look at a couple of other structures and we do some work. So what we're told is various values. Okay, we want to fill in the blanks. So let's have a look at beryllium. Beryllium, Be, periodic table. Atomic mass, you can get that from the periodic table. Mass number, you'll notice on the periodic table your mass number for beryllium is 9.012. You might think that's just rounded off. No, this is being calculated using information that I'm given. So for instance, I know I've got 4 protons because I've got an atomic number of 4. I've got 5 neutrons. 4 plus 5 gives you your mass number of 9. And then your electrons is just the same as your protons. So let's have a look at our other examples, and we're going to fill in the information we're told. Okay, so this one I'm not given a lot of information. I'm told an atomic number of 14 and mass neutrons 17. Let's fill out what we know. Atomic number tells me my number of protons, so that has to be 14. My number of electrons in an atom is the same as my number of protons, so that has to be 14 as well. My mass number is the number of protons plus the number of neutrons. So 14 plus 17, I have a mass number of 31. My symbol, now this is where I'm going to go back to my periodic table. Element number 14 is Si. Si, silicon. I'm just using information from the table to figure it out, plus using a periodic table. Let's look at the next one. A bit more information here. S. So we're going to have sulfur. So from periodic table, I've got 17 protons. Makes sense? I could have figured that out a slightly different way though, okay? Because I'm told the number of neutrons and I'm told the mass number. So mass number take away the number of neutrons will give me my number of protons, which would have been 16. My mass atomic number, same as my number of protons, 16 as well. Number of electrons, same as my number of protons, 16. Now again, for the next one, I'm not given a heck of a lot of information. I'm given mass number and number of neutrons, so 64 and 35. Basic maths, 64 take 35. My number of protons, 29. Okay, this tells me that my atomic number has to be 29 as well. Electrons the same as protons, 29. Now, if I go to periodic table, 29 is Cu, which is copper. All good. Now, the next one's a bit trickier. Bromide. If it ends in that IDE, it's an ion. Okay, in particular, it's an anion. So, we need to go and have a bit of a look at ions quickly, and then we'll come back and fill that out. If you remember what an ion is, it's a charged atom. They form when valence electrons are added or removed. Non-metals will gain electrons, so they get a negative charge. Cations lose valence electrons, so they get a positive charge. Okay, and the reason is there's a difference between the number of protons and electrons within that structure. More protons than electrons, you get a positive charge. More electrons than protons, you get a negative charge. So however many electrons are lost will determine the size of the positive charge. However many electrons are gained will determine the size of the negative charge. So how does this work with bromide? Well, bromide is a non-metal, so it is going to gain electrons. It doesn't have 36 electrons, does it? Yes, it does. I was meant to have deleted that. 35, 80, 45. Okay, now what we know, 35, so 35 protons, but it's gained electrons. Okay, and we'll have, if you can't remember how many it gains or loses, ask. Okay, I'll work you through that pretty straightforwardly. But effectively, bromide, gains 1 electron, so we're dealing with 36 electrons in its structure. What does this mean for its symbol? Well, it's going to be Br, but it needs the -1 charge up in the top corner. Now, I can't find my little button to make that a power, but that would be up as a power in the top right-hand corner of that symbol. Okay. Only other thing that we need to know about with atomic structure is what are called isotopes. Isotopes are where we have the same atomic number but a different atomic mass. So basically they're the same element, but the atoms vary a little bit. Now what happens, they still have the same chemical properties, they still react the same. We will get different physical properties, so they might even be radioactive. Okay. The mass number of an element's always a whole number. So when we get something like carbon-12, what we're talking about is a mass number of 12, a mass number of 13 for carbon-13, a mass number of 14 for carbon-14. What you'll notice for each of these structures is the protons stay the same, so it's always the same element. What's happening is we're getting a different number of neutrons within it, and that's increasing the atomic mass. What you will find is that one of your isotopes occurs more abundantly in nature than the others. Okay, so in this one, carbon-12 is your most abundant one. We use this to figure out the relative atomic mass. Okay, we'll do that later. We're doing that later on in the topic. Don't stress about that now. When you talk about these, though, talk about them as being isotopes, not as one being an isotope of the other. Okay, they are isotopes of carbon because they have the same atomic mass, the same atomic number but a different atomic mass, or They're isotopes because they have the same number of protons, but a different number of neutrons, or a variation on that, okay? As long as you've got that general gist. So that's atomic structure, okay? We're going to work through a heap of stuff on this now, okay? Ask any questions before we do so, but there's just going to be a lot of work on this for the next sort of lesson in a bit. Thanks, team.